Okay, so this video today plays on one of our need to knows, which is the following result. When we have sec squared, when we have sec of x, when we differentiate this result, it's very useful to know nice and quickly that this is the same as sec x tan x. Okay, so in the video today, you're going to see an example of how useful that is. Now, the first part we've got in this question is we're differentiating this, and this is going to help us with this very horrible looking integral underneath, inspired by some recent questions in lessons. So, first thing we're going to do is we're going to change how we write this. So when you're differentiating, because we are differentiating, when you're differentiating trig, the best sort of first step is to do something like this. Put the powers in a clear bracket on the outside. We're then going to do some chain rule. The innermost chain is going to be 2x, which is going to become a 2. Then we have, after that, we have sec of something. And then finally, we're going to have a bracket to the power of 6. So let's differentiate those things now. Okay, so I'm going to get 2 from the 2x. I'm going to get, well, what does sec differentiate to? Well, we just said that differentiates in general to sec something, tan something. And when you go back, you always sort of just write in what was there before, okay? So we'll just write this now as 2x, okay? And then the final one is the outermost one, the red one there, which is bracket to the 6. So bracket to the 6 becomes 6 bracket to the 5 in differentiation. And then, as we've just said there, you go back and you write in everything before. You don't change anything that was there from before. So sec of 2x. And there we go. We've got our first result. So just tidying things up a little bit gives us the result that this is the same as 12 sec to the power of 6 2x tan 2x. Now that we've got that then, this is supposedly going to help us with this result here underneath. So just take a quick moment at that and have a quick think. How could that be helpful? Now, I've jumped ahead a little bit to begin looking at our part B. So part B said hence or otherwise. I've got my results here on the right-hand side. I've picked these results because if I look at this, and I look at that, okay, I notice that this has sec to the 4, this has sec to the power 6, tan cubed, just a single tan here. It might be a good idea to try and trade, in this part, some of these tans into sec squared. That might be the way forward. So let's have a go at doing that now. So I'm going to write this as sec to the 4 2x, times tan squared 2x times tan 2x. I'm going to do a little bit of work with this. So over here, I've used my identities to decide that I want to trade out tan squared. So let's do that. So sec to the power 4 2x, and then this is going to be what? So this is the substitution. I'm going to say that this is the same as sec squared 2x minus 1. And then tan 2x. Okay, I've done that because it makes it look a lot more similar to what I had in part A. That was my motivation. If I expand out like so, what will I get? Well, I'll get sec to the power of 6 2x tan 2x, and I'll minus for the next one. I'll get sec to the power of 4 2x tan 2x. Now notice that the one on the left is looking really, really similar to what I got up here. I know that this differentiates to this. So I also know that this integrates to this. Okay, it works both ways. The only problem is this is 12 lots. I only have one lot. So what I'm going to do is I'm going to say that this, so I can actually you know, I can put some notation there. I'm going to say that this is actually going to integrate to a 12th. Think about why I've got the 12th, because you divide by 12 sort of when you integrate with that. So I'm going to divide by 12 when I integrate with it. And I know that the answer, I know this from part A. Okay? If you take a minute just to verify for yourself, you will see that that works. 6 over 12, 12 over 12, the number part works. Sec becomes sectan, sec to the power of 5 and a sectan together make this result work, okay? So this one here comes from part A. That's where I've got that one from. Well, can I have, there's multiple different ways you could do this one. You could do this with a substitution and so on, but I wonder if you can use this as a bit of a clue for how you do the next one. Notice that sec has this interesting property where the power sort of stays the same. The tan that gets taken care of, because when we differentiate this, sec goes to sectan. So you don't really need to worry about that bit. Well, let's just try, shall we? Let's try the result here on the right-hand side. So what if I tried sec to the 4, keeping it as sec to the 4 again, because we know that, yes, I'll just show you off to the side here. We know that, yes, you'll get sec cubed, for example, but then you'll also get sec differentiated, which is sec tan, won't you? Okay, so look, it actually preserves its power. So sec to the power of 4. And now we need to think about the number part, because at the moment, when I differentiate, I'll get 4 sec cubed. I'll get all of this, and then I'll also get a times 2, because there's 2x. These I will get from the chain rule. So how can I compensate against that? Well, it seems as though it needs to be minus an eighth. And in fact, yes, that is the final answer if I put it with a plus c. Okay, so there's lots of different ways you could do this. You could do this as well with the substitution, of course. But I'm using the part A to help guide me a little bit. And I'm using fundamentally the idea that sec differentiates into sectan. And sectan then differentiates into sec. It's got extra layers on it, okay? There's a chain rule going on, there's numbers going on. But that's why this is our need to know that we're covering today.